Good morning. Well, I'm glad to see you all made it bright and early, and I am Rick Luecht, and now at the University of North Carolina, as it says, I want to thank first Cindy and certainly the entire Keynote committee. I do have some notes, but I'll probably not look at them. I never do that for my classes either, so the students never know whether I'll talk about the book or something else. I want to tell you a story this morning, though, and it's a story about testing as it's come through, and I thank Cindy for the wonderful introduction and talking about innovation, because that's what this story is about. But the story's not about me as the innovator. The story's about all of you as the hero of this story. And so as this story unfolds, I want you to really think about what you can probably do, what role you can play as the hero, as the innovator yourselves in taking this message forward. So it's a very, I think, important story. It's a time in our existence where, as an industry, we really need to think about perhaps changing. So Cindy had a few facts about me, but there's some other facts. She mentioned the hockey. I am an athlete. I am also a very sensitive husband to my wife, Vicki, and of course a scholar. An academic, and so I'm proud of all those accomplishments. And I also enjoy a lot working with many of you, many friends, many colleagues through the years at many organizations. And so as part of this story, I want to be able to begin with a very simple concept. My talk is entitled Version 2, and so I think it's important to think about the idea about what a version is. And the definition that comes certainly out of software engineering is a version is a qualitative state change. It's not just a continuation or minor improvements. It is a major innovation, a major jump in technology. And that's really what I see happening now, where we need to move in testing. We've made wonderful accomplishments for the last 100 years in testing, but I think it's time to move beyond where we've been and move to the next step. And many of the techniques, the models, the technologies, the way we approach things have to change at a philosophical level, as well as at a level in terms of day-to-day practice. So in thinking about our versioning here, I want to be able to go through some of the techniques that we use in terms of current techniques for building testing and seeing where we've come from, and then lay out some ideas about what version 2 might look like for you. Well, how we got here is certainly, depending who you look at, the history of testing goes back to somewhere around 2200 BC in China, and the most documented cases were about 600 AD with China's imperial examination system. And then certainly in the US, we had changes that happened with the US civil service exams, and moving on to the alpha beta tests for around World War I, and then Stanford Achievement. And then some notable individuals. Galton's often credited as the father of individual differences. Cattell's work also on intelligence, and of course everyone knows the Binet test that became the major test of intelligence until Wechsler and some others came along, and Terman made some advances in that regard as well. If you go all the way back to the 1700s, Bayes' theorem that was later improved by Laplace and some others, and Galton again came in as kind of the father of correlation, who led to Spearman and Carl Pearson and some others, Kelly and Thurston, and it continues on to the into the 40s with Paul Horst and Thurstone and Fred Lord, and now we have Ron Hamilton and Wim van der Linden and some Bob Brennan and some wonderful individuals who have certainly been mentors to me through the years, and I certainly appreciate that. So where is it now and where is here? Well, we are a multifaceted industry. It's not just educational testing. It's not just certification licensure. It's psychological testing, language proficiency exams, again, graduate exams, entrance exams, military exams, and of course IQ exams, which have been there from the beginning. So we've got this long history. And by the way, I wanted to point out I'm wearing a black coat today, and that's a purpose for it. There are no company names here, but I am willing to sell space on my coat for endorsements. If you'd like to put a logo, it's per square inch. So just see me after the talk. But we have grown from paper and pencil testing to essay exams to case simulations to computer-based testing, and now we're even starting to talk about something really great, which is even putting testing perhaps onto iPods or iPads, putting it onto smartphones, getting it out so we can create the capacity that we need to be able to do testing anywhere, anytime. But that's also what creates some very new challenges for us as an industry. If we want to be able to test every day of the year and give teachers, for example, tools that would allow them to test a new set of constructs in weeks 1 to 2, another set of constructs in weeks 3 to 6, on through 16 or 18 weeks of a semester, that's not the same model that works when you're doing 2 days of testing a year or 4 windows of testing per year with some of the exams. So I want to mention that now because it's a really important part of this theme that's calling for version 2. It's the part that says we really need to move beyond this thinking. We can't simply recobble the existing systems and thought patterns of yesterday and today and make those work tomorrow. Now, I'm going to talk quite a bit about constructs, and it's an important concept. In measurement, we use this term construct, but what does it really mean? Where does it come from? And I put these version numbers up, and when you create a talk like this, you get to make up your own numbers, and I'm a psychometrician, so I do it as well as anyone. And so I'm calling this version 1.2 that goes a little bit beyond the beginning, that everyone knows about a content blueprint, okay? And it's where we specify how much of the test fits certain content areas. And we go to subject matter experts, SMEs, and ask them to build these blueprints for us that give us the important layout of the test. And later on, we can build them so they match this kind of specification. There's also been other developments under version 1.2, which were the developments in factor analysis, in early IRT, to basically say, get a data set or get a correlation matrix or a covariance matrix, do these things as psychometricians we enjoy to do, fit it with a statistical model, and then name that construct game, which is to basically say, see if we can add some meaning to it after we've derived the statistical notion of the construct. This is what I believe has to change. We have to rethink from the beginning, but I'll get to that in a bit. We've moved to maybe version 1.5 to 1.8, which is structural equation modeling, and we get very pretty pictures, such as at the left, where we're now able to say, well, I think I want to measure these 3 things, or these 2 things, achievement and motivation. So can I fit a model and show that that's the truth? Can I confirm that? Can I confirm that? And we've moved beyond that. I've done a little bit of work, and Wim van der Linden's done a lot more than me, on using test information functions at the right, which is basically saying, where do you want to put your items to gain the precision that you need to make good pass-fail decisions for certification exams, to build a good achievement test, or even to build good tests for patient self-report in areas like quality of life studies. So we've built this, and we've got these great models with this that we can use automated test assembly nowadays and get hundreds, or at least many forms in literally seconds, where it used to take weeks to build test forms. Now, let's move on to items. And items for me are an interesting thing, because with the invention of scanning machines, and even a little bit before that, we had this notion of selected response items. And in all the variants, whether they're sort of drag and drop or building lists or all the other variants, they're pretty much still selected response items. In fact, I don't think it's inaccurate to say probably 99% of at least our professional tests are built using multiple choice tests. And we're trying to move away from that, but there's a danger in doing that. When you begin to move away from that without an idea of the construct, you let the item type drive the process. And we've moved to some good examples there. We now have hotspot items, items that have video clips. The National Board of Medical Examiners has a computer case simulation. The American Institute of Certified Public Accountants has an accounting simulation. And many others are working on these types of things. And we're calling them kind of technology enhanced or innovative items. But there's a problem with doing that. When you build an item type, again, without the construct, it's sort of like writing a love letter. Okay, and some of you probably have done that in your lives. Writing a love letter to whom it may concern. Right? I mean, you got a great item type. Now, throw them out and let's see if we can build something with them. You get back then to the early parts of saying you do factor analysis and other things to try to build a construct from it, rather than having the construct in mind and making the item type be in service of that construct. And you're going to hear this word design, design, design. It is by design. Those of you that have worked with me know that I think a lot about what I call assessment engineering, but it's really that principle of saying, don't just build it and hope that it works. Build it to a design, tweak the design, make the design better, but keep iterating that fact. Now, in terms of score scales, we started out with simple score scales. Simply add the numbers up. If you add those ones up at the top of the screen, they do actually equal 6. I checked myself twice. I do good quality control. We've got linear models, all these kinds of models to put together scores. We can compare your score to a normative group and get how you would perform in terms of the bell-shaped curve over at the right-hand side there. And of course, we can do other types of models to get us a score. Okay? And this is certainly, again, something we've done from the very beginning here. We've actually moved beyond it. We've moved far beyond this here in terms of designing score scales. Now, not only do we have very wonderful classical equating models to equate some of the largest exams in this country, but we also have all sorts of IRT models for different types of data. We have scales or scaling techniques that can give us what we would call the latent class type things. People call these diagnostic classification models, multidimensional models at the bottom right that really let us see how you perform on multiple traits at one time. And all this are very good, very excellent mathematical work, statistical work by the people who have developed these models, developed software to use them. Okay, there's a problem here with models, and it's not with the models, it's with the situation. If you begin to test everyone, as I said before, over every day of the year, or a teacher tests them for 2 weeks now and then changes to a new set of constructs at the 3rd week, and we continue this process of more and more testing, statistical models have a very simple thing. They need lots of data. So the big forms where we had hundreds of thousands of kids taking them before now are being stretched out, and the linkages among those items, among the test forms, the sample sizes, the number of examinees taking every item starts getting very small. Those same statistical models that were wonderful with large samples may not work as well, or the assumptions we make in order to use the models may not work as well. And again, it's not a criticism of the model. It's a reality of the situation of where we need to move to if we're going to put testing in the hands of teachers. Okay, if we are actually going to give them the tools, if we're going to give you the ability to let your people test whenever they want, in whatever environment they want of the future. And so we really need to think carefully about how can we help in an efficiency standpoint to help those models not have to work as hard. Okay, how can we deal with these realities here? Now, we've also done a good job in terms of building interpretations of these score scales. We have percentile ranks, how many people scored at or above in terms of some reference group of examinees that took them in spring or fall of the previous year. We have wonderful techniques in standard setting that help us identify just competent or barely competent, minimally competent examinees, and then sometimes we talk about the percentages that pass or fail in terms of first takers, repeaters. That is an interpretation of a score scale. Groups like NAEP and most of the states that are now doing K through 12 testing for accountability purposes use academic or achievement level standards. You're below basic, you're proficient or you're advanced. And depending on what content area it is, there are these achievement level descriptors or proficiency level descriptors that people use that are an attempt to interpret the score scale. Okay, when you're below the score scale, you can do whatever the basic says, or below that, what below basic says, etc. We've gone beyond that now. Groups like NAEP are now doing work with something that's called scale anchoring. Now, what scale anchoring is basically to take the statistical score scale you have and add very specific interpretations of what it means. And you look at prototypical items and you see how they perform and you say, well, when you're at this point of the scale, you can do this kind of item with 60% or 80% accuracy. And so it gives us a sense of interpretation. It really sounds innovative, and it is. But there's an issue here. What about that construct at the beginning? Is this really the intended construct? And we're really applying the interpretation in a very ad hoc, after the fact way to what we should have built in at the design stage. And I'm not the only one saying this. I mean, Henry Braun and formerly of ETS and now Boston College and Isaac Behar of ETS, they're saying the same thing. They call it proactive standard setting, but it really is building the interpretation. And once you have that interpretation, designing the construct and everything that goes with it to meet that interpretation. Design, design, design. I really was actually happy with this little graph. It's a vague attempt, and there's no scale because just like my versioning there, I made up the numbers. But I think it actually is not completely inaccurate, at least. Technology has taken off. Certainly since the 70s with the advent of personal computing, and now moving forward with smartphones and all the rest of the technology that's out there with cloud computing, et cetera, we just continue to grow on a technological front. Since certainly even the 50s and forward with the advent again of equating methods and now many IRT technologies and the more recent diagnostic classification models, psychometrics has moved to new heights. Okay, and it continues to grow. But it's interesting that how we think about test design, how we think about item writing, how we think about test development has still pretty much flatlined. We're still doing 99% multiple choice items. And again, it's not that the multiple choice are bad, it's that we're not thinking about the constructs. We're not thinking about the constructs. We're using the statistical models, the data-hungry statistical models to build things out. So what I want you to think about today is your role is how can we move things forward this way? And what should version 2 be? And now, anyone that's out there that's a software person, you'll probably recognize this as kind of a paraphrased version of rational unified process. But the idea is that we want to base version 2 first on really asking, what do our users need? And in psychometrics, you talk to psychometricians and they say, well, what they need is, it's the purpose of the test. Well, you need to go beyond that. What do they really need? My passion is education, K through 12. It really is. And I've worked in certification licensure a good part of my professional career, but my passion really is, the reason I got into this was because I believe in using tests to make teachers do a better job. And not to make them, to help them to do a better job. And so I really want to ask, how can I help them? How can I help them to make better interpretations, not just to hold them accountable for what their students do? Okay? I want to help the students to actually improve. And so I want to really listen to them as my primary stakeholders. I mean, I work in a school of education. I work with school superintendents and state people. And if you're here, I apologize for the statement to come. But I don't really care about the accountability. I do care about helping kids to learn. And I care about helping teachers to do a better job. And so I want to listen to that. Listen to what they need to do a better job. Help them along that task. Help them to devise constructs, tools to measure those constructs, and items and tests that actually give them usable formative information that they can use in their daily lives. And I think that same belief, that same thing extends to all of those other areas of testing we've talked about, doing a better job. It also means that we need to get things out there. Cindy was kind enough to sort of mention me as an innovator. I don't believe in doing functional requirements documents and then going out there writing software for a year and a half, hoping that maybe it does something, put it in the user's hands, and they say, this is nothing that I thought I was looking for, right? Get it out there. That's the whole purpose of iterative or the RUP, Rational Unified Processes. Get it out there, iterate, repair, refine, get it working right. And we need to get that out there quick so they know what we're giving them is not a top-down thing that's being forced on them. Architecture base. If you cannot replicate, scale this thing up to being able to test every day, it's not usable. We have to stop thinking about items as this unique instance that's always presented in a certain position on a test for a certain type of content, has its own unique statistics, and then we throw it away. Okay, many of you deal in testing programs where item costs may run from anywhere from a couple $100. I've worked on programs where they're $1,900 per item when we've costed them out. That's an expensive commodity. You don't want to use it once and throw it away. Okay, I mean, I don't buy a set of golf clubs, use them once. I'm very bad, by the way, at golf, or I would have put the picture up. But I don't buy a set of golf clubs, use them once and throw them in the garbage, or use them twice at most. You want to be able to use this stuff over and over again, which means you want to build models that are very robust. If you cannot draw it, if you cannot model it visually, I always say it's kind of a useless thing. So when we talk about maps, construct maps, or task models, write it down, draw it, draw the pictures. Let people understand it visually. And this is a new part of software design that's, it's been around for a while now, but certainly has worked there. Quality control. I see psychometrics as not the way to build the scale from the ground to extract signal from the data set, but actually a way to engage in quality control to make sure that these families of items are working the way that we want them to work. And then finally, always keep control of everything so that you're making sure, again, you're constantly improving, working forward, that it all fits together. Okay? Now, wrong way. There are basically 5 functional requirements that I see us having to engage in for this version 2. The first I've already alluded to, which is to build constructs as scales. And this may sound strange, but I always make the comment of saying to my colleagues in psychometrics or in statistics, for me, constructs, factors, scales are the same thing. Okay, they're the same thing. There's no such thing in my world as a multidimensional construct. There may be multidimensional constructs, okay, but the idea is you have an intent, you want to measure it, you want to write it down, draw the pictures, okay, and recognize at the end you're going to get a scale, whether it's a pass-fail or a set of numbers from 200 to 800 or a number from, 1 to 36, whatever that is, you're going to need a score scale. Start talking about that score scale and its meanings from day one. Secondly, I'm going to say a little bit about task models, and I don't want to get too much into that today, but it really is, to me, the heart of what we need for version 2, which is to replace those current blueprints with an integrated specification where statistics, the performance of items, and their content as well as their cognitive skills and declarative knowledge components, all this stuff we talk about at a technical level, are carefully integrated into the design. So when you pick a task model, 5 or 50 task models for a test, you've actually built the test. You don't need any fancy automated test assembly or anything. It's designed. Evaluation and design of templates. This is how we control difficulty. Okay, if items are working well, they have very tight specs. All the items work the same that belong to the same family or template. Okay, and I'll show you some pictures there. And finally, we've got the psychometric center in, where we do have hierarchical IoT models and techniques, and Vim and Case Glass have done some wonderful work in that regard to think about design parameters and calibrating those. Since we built this all around the construct from the beginning, when we put it all together, the interpretation should fall right out at the end. We've already built it, again, to design. Now, a construct map in a vague sense, again, is designing a scale. And this certainly is a very kind of a 50,000-foot construct map, but you begin to write at certain points of the scale, what can people do? Okay? Even people at the low end of the scale can do something. What is that? What do you claim they can do? What do you expect them to be able to do? Okay, and as you move up, they can do more complicated things or work with more complicated data or knowledge objects. Finally, they can do very complicated things with very complicated objects. And so I don't want to just use words like, well, it's integration or it's synthesis or kind of the Bloom's taxonomy stuff. I want to define what that means and what kind of data they're working with when they do those things. Okay, and so we talk about writing action verbs and creating dictionary lists. And the same action verbs may have different meanings for different constructs. But write it down, draw the pictures. Now, at the left there is a simple example, and this gets into this idea of multidimensional versus unidimensional. Most of our item banks now are built for unidimensional tests. So the idea is this sort of pictorial display shows at the bottom you can deal with simple knowledge objects doing simple things. As you move up, you can maybe deal with a few more objects and slightly more do more complex stuff with it. Finally, we move to relations among sets of objects, and finally to a system of objects where we're doing some fairly complex skills. And again, this is it's an exemplar only. It's not an actual construct map, but it gets you the sense that you can have compensatory skills built in, but you have to imply that anyone who's at the top of the scale can do everything below it. That's what's required from a scaling standpoint. Since we need scales at the end, let's build that into our definitions. Okay, multidimensional formative assessments. Sorry guys, and this may tick a few of you off, but you cannot repurpose your unidimensional item banks and start doing strand scores and pretending like you're actually giving people diagnostic information. And I'm happy to debate that and show you examples where we look at disattenuated correlations or things between your traits. The reality is the profile you should be giving the examinees is flat because they're all sort of bad estimates of the total score. If you want to build a multidimensional test, a formative assessment, scale it with diagnostic classification models, scale it with multidimensional IRT, scale it with multiple unidimensional IRT models, use sum scores. Whatever you want to do, you have to think about designing multiple constructs. Designing a construct for each of those things. And this was actually a little construct we did last year for AERA. Mark Garrell and I were working on some stuff for a set of algebra constructs that could actually be used in a classroom. And there was more detail to it, but it really works well. Now, from those constructs, the idea is then to build what would it take to convince you that somebody that's at this point of the scale has the skills? And you really need to go through those exercises. And one of the things I found effective is using what's called a cognitive task model. And people have different variants of this. I use a little mathematical formula called a predicate calculus form. But the idea is that people do something with some objects, and the objects may or may not be related. And then each of those objects, actions, and relations also have attributes and properties. Now, if anyone's out in the IT world out there as programmers, your eyes are starting to probably light up a little bit because, yes, this is object-oriented design. And that's important because the specification for the task can actually be represented in a database down the line. So again, it's a way to think about not only the scale that I'm going to have to get to, but the data. I haven't written a single item yet. I'm thinking about what it's going to take to give me the evidence. I'm self-validating the construct as I go along. Okay. Now, the idea of the task models is task models are actually at the top of the hierarchy. They're the cognitive specification, not only, again, of the skill, but also of the objects and relations among the objects. They specify the challenge every examinee has to go through. That's my new content specification. This challenge, it's like a video game, right? The examinee has to accomplish this task in this amount of time with these resources. And you specify that and tighten it up. The template is a way to make that happen. It's a way to control the data, the rendering form. Every task model has multiple templates, so we don't get accused of narrowing the construct down to a certain specific item type with certain features. And every template creates lots of items. Okay, it all actually works. And you can have different task models that give us different characteristics of the actual test form. They can be spread the information out like a normal curve, create it sort of flat across the distribution, put it in as shown in the lower left there as points at the basic, proficient, advanced cut scores. If you're looking at it, it looks like an information function, but it's actually a distribution of how I want my items to appear. And again, I haven't created a single item yet. I mean, I can start that task, obviously. But the idea is I've got an exact specification, not only for the construct definition, but how I want to design that test, how I want to design my items, my item bank to give me the interpretation and the meaning I need. And then you can actually think of it here where we've got this distribution. These are sort of low-level type task models where you're doing recognition tasks, some fairly straightforward things with a few things. And you see, the task model doesn't look like a content blueprint. You know, it doesn't say algebra or two-digit number. It's a very complex specification, and even these are even smaller than what we'd often write for these. So they're really thinking about what I want the examinee to do, what skills and knowledge they need to bring to bear. Here's at the top end of the scale, again, we get into solving complex problems, and we also specify solving them with what? What kind of data? Are they dealing with a system of equations here? Are they dealing with large data sets, et cetera? All of those things have implications for how difficult or how easy the items become. This is not a template. This is the cognitive task model. The template actually takes on a rendering form. And when I talk about these things, I talk about the rendering form and the data model and the scoring evaluators as comprising the whole template, how you're going to score it, how you're going to actually represent the components that go into the database that become the things you fill in the slots. But here you see at the left-hand side what the task model looks like, and the rendering form is basically a shell for something like automated item generation. Okay, and so the idea is that from that one template at the right, we can move forward quite a bit now to build lots of items with the same cognitive interpretation, same challenge to the examinee, same position on the scale, same inferences being made. Now, just to show you that, for those of you that are worried about, well, what does this mean to me? Okay, remember I said about the hungry data models? Where you're stretching this out. Now you may only have a couple of hundred examinees taking every test form. Well, if we can kind of do this as templates at the far left, this list of the CPE 01 out down to CPE 010, this is actually some work that my colleague and friend Mark Garrell worked out for automated item generation with some of those previous models I showed you. And you're producing for one task model as many as 10,000 items. Guess what? If it really works tight and you do the psychometrics to tighten that template up, or all of these templates, maybe you throw some out that aren't working well, you may get hundreds, thousands, tens of thousands of items for every task model. Guess what? Every teacher can pick those items any day of the week. If you're in certification licensure, those worries about the security of the pool or having to do exposure controls, not a big deal, because you've got literally thousands or hundreds of thousands of items. You know their characteristics, so the exposure isn't a big deal. You calibrate the task model or the item, okay? So all of this stuff, I think there's enormous economic benefits. Bob Whalen yesterday mentioned the economic side or the business side of psychometrics versus the science. Well, we're seeing, the science is test development, test design, psychometrics, operations. Okay, but there's even something for the business folks here in that you can actually turn a profit. You have to invest in the front end side to devise these, but the payoff at the back end side is enormous. I started out in manufacturing after I sold insurance and worked for General Electric. And we didn't let artisans out on the floor to craft parts for CT scanners, right? For computerized tomography. We actually had engineering specifications, built assemblies of parts the same way over and over again so you could mix and match and put things together to spec and build things that the customers actually knew would work the same way every time. That's where we need to go to. It is engineering, it's design. Now this picture I've shown before at other talks, so if some of you are going, I think I've seen that. Yeah, you've probably seen it before. But it really is the thought of a whole system, moving from construct maps at the side to a specification of what I call a task model map, writing out, working with those task models. Again, it's iterative. I don't sit in the room in my office in Greensboro, North Carolina, and just think about this, write it down, and get it right the first time. I invest in a lot of iterative design, working over and over again to get the templates right. I may lose some templates. Some templates may not create a lot of variations. I'm going to use the hierarchical calibration models to get the variation of difficulty down. And guess what? If I'm wrong, if I'm completely wrong this morning and 10 years from now, you all say, well, that was kind of a stupid idea. And I may agree with you then. But if we're completely wrong, we do what we do now. We calibrate the items as individual entities. We pay the $350 to $1,900 per item and kind of live with it. Okay? And so as we move forward, I'm really thinking about this version 2 as doing several things. Constructs by design, making it work. Doing evidence-based task models by design that really fit where, putting the tasks to give us the kinds of interpretations we want. Building in useful interpretations by design, not adding them on after the fact, after the score scale's been built. Item production, not only for low cost, but also for security, and also to allow the teachers or anyone else out there to use these on a regular basis. And certainly the security goes without saying. I mean, that's sort of the scope of what I see as version 2. Now, I do want to mention, though, that, as I said, my interest, my love has always been putting testing assessments into the hands of teachers. And I don't mean teaching them the definition of reliability and validity or teaching them to do an item analysis with 30 kids. I mean giving them tools that let them create informative, sensitive metrics that they can use and actually see progress in their kids. I want them to teach to the constructs. I want them to teach to the test because it's going to make a difference. And so I really want to move from the point of what is, the point where teachers hate us. Sorry to tell you that, they hate us. Okay? Students don't like us very much either. And I want us to move to a point where we are loved, respected. Maybe that's asking a bit much, but I do see if kids can get engaged in assessments where it's not a scary type thing, where it's actually a part of their everyday instruction, becomes informative, and the teachers no longer see this cloud of accountability holding up, maybe we can actually make a difference there. So I want to leave you with this one thing, which is a test. Does anyone know what this is? And think about yourself. Okay. If you figured it out, this is a seed. My idea was to leave you with a seed today of what version 2 could be. And I hope you take that seed and help nurture it. Think about your role in this and how you can make it grow. Thank you, and enjoy the rest of the conference.